steps to solve standard minimization problem. First step is find the dual problem, which would be standard maximization problem. So we have to write down then its simplex table for the dual problem. Then we have to perform pivoting and find the final table, and from that final table we have to read it for the standard minimization problem. So let's go step by step. So first we find the dual problem, step 1. So in order to find the dual problem, so we would write uh, these coefficient and constants given in the original problem in the matrix, and our variables are like say y1, y2, y3, right? So this one, and we write down this matrix. The coefficients start with from the first inequality here. It's coefficient, so they are 1, 3, 2, 1, 3, 2. Then we from the second one, so we have 2, 2, 3, 8. And then the coefficients from the objective function, they are 2, 8, 10, 0. The next we have to take a transpose. It means that changing rows into column. So first row become first column here. So this first row here, this become first column. So like 1, 3, 2, 9. Then similarly second row becomes second column. So that's 2, 2, 3, 8. And third row becomes third column. So 2, 8, 10. So from here we would write our next dual problem. And if the original problem has a variable like y1, y2, y3, so the dual problem would have, we assign the variable x1, x2. And you can see that here, so from the left of this vertical line, so there are only two columns, so we would assign first column with x1 and second column with x2. As we know that if the original problem is a standard minimization problem, we have to minimize it. So the dual problem, we have to maximize it. So we are writing from here our dual problem. So that would be maximize. So and maximize, we say uses symbol z as objective function. So the coefficient would be like say 9 x1 plus 8 x2. That's from this last row here. These variable x1 and x2. And subject to so from this first lines you write your first constant, so that is 1 time x1 is x1 plus 2x2, and you also know that the inequalities you have to reverse. So here in the original problem the inequalities were like say greater or equal to, so your inequalities should be less or equal to, and then this here. Similarly from the second, so we would have 3x1 plus 2x2 less or equal to 8. And then from the third one, so and again we would say that these x1 and x2 they are greater or equal to 0. So this is our step 1. So we found it problem. So that's a dual problem to the problem. So next step we have to write down its initial simplex table. So that first we have to add slack variables and then write down the simplex table. So from the first inequality, so by adding slack variables, so this would become equations x1 plus 2x2 plus S1 to 2. Similarly, second one become X1 to 2 to 8, and this third constraint X1 plus X2 S3 to 10, and then rewriting objective function in the standard form. So this would be negative 9x1 negative 8x2 plus b 0. So from here we would write our initial simplex table. So on the top I would write variables. Our variables are x1, x2, and then I have s1, s2, s3. So this is initial simplex table. This was step 2. And step 3 is that I have to perform pivoting. First I have to find pivot. So the most negative indicator is this one here. So pivot would be in this first column. So first I have to check the ratios because 1, 3 and 2. So in the first column all numbers here above horizontal line are positive. So anyone can be pivots. We have to check the ratios. So for the first one to determine this one, so I have to check the ratio as 2 by 1. This is the first row, the last number divided by this 1. Similarly, in the second row, the last number is 8, so 8 divided by this number here, 3. So that is 2.666 divided by 2. So for the third row, so last number is 10, so 10 divided by 2 equal to 5. And we can see that among these three ratios, so this one is the first one is the smallest in the first row. So this would be pivot. Pivot would be in the column with the most negative indicator and then with the smallest corresponding ratio. So first row and first column. So this is our. So to perform pivot, we have to make zeros in the column. First column, everything other than this pivot itself, right? So we have to make this 0, this 0. And to do this, our operation would be 1 plus row 2 is in row 2 and negative 2 times row 1 plus row 3 is row 3 and 9 times row 1 plus row 4 is new row 4. So pivotal row as it is. So like 1, 2, 1, 0, 0, 0, 2. And then by performing these operations, so my this next table would become. So now in this table, you see that all the indicators here, so they are non-negative. So it means that this is final table. So we have to now read it, but we have to read it for the original problem. So this table is for the dual problem, but from here we have to read it for the original problem. So for the original problem, so because the dual problems, they should have the same solution. So W would be the same as Z. So we would say that W is equal to Z is equal to, in this column, if you see that, only one non-zero number, that's 1. So Z value would be 18 by 1 is equal to 18. So W would be 18. And we have to read values for the variables of y1, y2, y3, because if you see that in our original problem, so our variables were like say y1, y2 and y3, right? So to read those values for y1, y2 and y3, so you have to look for under S1 this last number here, this, right, under S1. So last number divided by this number here, this one under Z. So there's your y1. So y1 would be 9 divided by 1, which is equal to 9. Similarly for y2, so you have to look under S2. So this last number here, 0 divided by this 1. So 0 divided by 1 is equal to 0. Similarly, y3, you have to look under this third, under S3, this column, under this. So this last number is 0 here. 0 divided by 1, so that is 0. So our answer would be then for the actual problem that the minimum W is equal to 18 at y1 is 9, y2 is 0, y3 is 0. That is the final answer.